excited to wake up this morning and see snow, and I ran around outside, and I was like taking video.
Did you slip again?
No, and then I realized I didn't have any socks on, which is why I was so cold. Lots of fun, lots of fun, lots of fun. Alright, so two things just got passed out. Number one should say release free response questions at the top. Did everybody get one? Okay, so this is not the homework. This is this is not your homework. This is your opportunity to improve your grade by getting rid of homework assignments that you have not done. Okay? There are 4 questions, so like flip through it. Now you might be like, hey wait, you didn't double-side it. You're right, I didn't, and I did that on purpose. Although, do you guys only have 3 pages? Yeah. It should be 4 pages. I only have 3 pages.
I got 3.
We have 1, 2, and 4.
Pages 1, 2, and 4. Okay. So something has happened with page 3. I will get to the bottom of that. Jeanette, thank you so much.
It's the middle question.
Okay.
Because there's 1, 2, and 4.
Right. No, you're right. I figured it out. Okay. So just to be clear on 1, 2, and 4, there will be a 3. I'll get it to you on Monday. Okay. These are the bonus things that you're going to do. Number 1, to get ready for the semester exam. Number 2, to dig out of whatever hole you might be in. Okay. In order for you to get your homework grade thrown out, you have to do this problem first on your own with no help from anybody. You give yourself 15 minutes, and the instructions are right at the top. 15 minutes to work through this problem completely on your own. Very likely, it's not going to go well in that first 15 minutes. You're going to start wondering what the heck is going on, why am I not doing so well? Partly because it's been a while. I know. Everybody okay?
I don't know.
Axel, do you have a whisper button? Find it. Okay. Okay, so that's the first part. Part number 2, if you look at the very top, there is a link to the video. I've worked through this problem. It's available online. The video length is 15 minutes and 4 seconds. Not too long. 15 minutes for you to work the problem, 15 minutes for you to watch the video and take notes. If you don't take notes, nothing's going to happen. And then the last thing is you're going to do a quick little summary, 2 to 3 things that you forgot about that you remember now because of the video. At that point, you tear it off, turn it into me, I look over it. If you did a really good job, your lowest homework assignment grade is removed, and you get a 100 if you've done a good job. Everybody okay? Mm-hmm. You can do this up to 4 times between now and next Friday at the start of the exam block. Once the exam block starts, no more. Eval and then Roberto.
What if on Wednesday you did 2 first 2 videos you uploaded and we turn that in?
So you've already like taken notes on? Yeah. Wow. Way to go, eager beaver. Okay, yes, you can turn those into me after you have also like given me like your summary of like here are the things that I learned. Sheila.
Can you turn it all at once, or does it be 1 by 1?
100% your choice. 1 by 1, all at one time. It does not matter to me. The sooner I get it, the better, so you can see how this is impacting your grade. Roberto, you had a question.
Oh yeah, you said how many other? 4?
Huh?
How many other?
There should be 4. Unfortunately, we had a copying issue this morning. There's only 3 there. For the BC friends, I've got 2 more videos to film this weekend on rate functions. I'll give that to you guys on Monday. Okay? All right, so there's that. Second thing that you guys have, it says blast from the past. Okay, this is the homework. Okay, tonight, this weekend, for homework, you're going to do, it sounds redonkulously long, pages 1 through 8. Now, before you completely freak out, because these are multiple choice questions, there's actually not a whole lot that you're going to do. It's like 20 problems max. This is going to cover Unit 1, like limits, slope of the tangent line, baby derivative stuff, and then Unit 2, f prime, f double prime. You should use your notes. You should work with one another on this. Jackie?
So 1 through 8, do you actually mean 1 through 6 and then A, B?
I mean pages 1 through 8.
Oh.
pages 1 through 8. Okay. All right, we get 4, we get 8, we get 12, we get 16, 18, 22, 26. Who's missing?
Gonzalo.
Okay. Well, the good news is Diego's here. And hi, Beto. Can you make it way quick? Okay. So good news is that Diego is here. Even better news, your birthday is Sunday. So a little bit early, but I'd rather sing it early than late. Here we go on the count of 3. 1, 2, 3. Happy birthday to you. Happy birthday to you. I know we're all jealous. Happy birthday, dear Diego. Happy birthday to you. Bravo, bravo, bravo. All right, I am available for lunch support today. If you guys could take out the Unit 4 test corrections and reflections and put those in the middle of the table, that would be greatly appreciated. If you are not finished with it, you do have until the end of lunch today to get that taken care of. After that, Circus Boy Crazy will be visiting your home. Okay, maybe not actually your home, that would be creepy. But Circus Boy Crazy will be visiting your lunch, so please put those in the middle of the table. Jalissa, if you wouldn't mind going around and picking those up, I'd appreciate it. Jackie, this is for you. Jose, can you pass it over to Jackie? Thank you. And if you guys could all take out the homework that you did last night. I hope the homework went well. Please grab a marker. And we're going to go and do these quick like a bunny. Okay, Jalissa doesn't seem to be picking up as many test corrections and reflections as I thought she'd be picking up. This must mean that people are planning to stop by during lunch to finish this up. That must be what it means. All right, so here we go. Question number 1 from last night's homework. The integral from 0 to 4, square root of 64 minus x squared in the calculator, 30.611. Your estimate is going to be 1 times f of 0 plus 1 times f of 1 plus 1 times f of 2 plus 1 times f of 3, and you get 31.099. If you're getting these right, just check, check, check. The estimate is going to be an overestimate. Now here's the thing. You have to tell me if it's an overestimate or an underestimate, why. And the why has to do with the method and the graph. So why is this going to be an overestimate? Because the rectangles contain more area than the graph is part of it. The graph is decreasing and you've got a left endpoint method. Karina.
Would it be the same instead of putting f of 0, you put f of 4?
No.
Okay.
You don't.
Doesn't the left point method leave space in between, like inside of the circle? So wouldn't it be an underestimate?
Not always, and not for this graph. The graph that you had was the graph of the square root of 64 minus x squared, which looks like that. The left endpoint method, your rectangles look like that. It's because the graph is decreasing and you're capturing more area. Henry.
So when would it be like inside?
When would it be inside? Left endpoint method over here.
But that left point was underestimate.
No, I have never in my life said left endpoint is an underestimate. It has to do with what the graph is doing. Over here the graph is decreasing and those left endpoint method, those capture more area than what you want. But over here when the graph is increasing, you're capturing less area than what you want. It has to do with the method and the behavior of the graph. Are we okay? All right. How could you make the approximation more accurate? There's only one way to really do this. More rectangles. All right, 2a. The integral from 1 to 6 is 35.033. So you find the area for 5 rectangles. It's going to be f of 1 times f of 2, 1 times f of 3, 1 times f of 4, 1 times f of 5, 1 times f of 6, for an answer of 33.626. Now, because these rectangles are below the graph, this is going to give us an underestimate this time. Okay? And then your setup, what if you wanted to do this with 10 rectangles? Well, what's different is the width of each rectangle is going to be 1/2 or 0.5. So you'd have 0.5 times g of 1.5, 0.5 times g of 2, 0.5 times g of 2.5, and so on and so on and so on, all the way out to g of 6. And I hope everybody's doing okay. All right, number 3. Yep.
Like for your song, so we have to show like all the work, like right after.
Yep. All right, number 3. What are we doing? Is this the midpoint method?
Yeah.
Okay. So the widths are 1. You've got g of 0.5 plus g of 1.5 plus g of 2.5, g of 3.5, g of 4.5, g of 5.5, 6.5, and 7.5 for an answer of 50.506. 3b. G of negative 3.5, G of negative 2.5, G of negative 1.5, all the way out to G of 3.5, and we're getting 61.271. Are we doing okay? Okay. All right, 4a. These must be trapezoids, right?
Yeah.
All right, 1/2 base 1 plus base 2 times your height. 1/2 base 1 plus base 2 times the height. Going and going and going. Final answer, 47.931.
Yeah.
And then 4b, the integral from 0 to 5 of g of x dx for trapezoids. 1/2 g of 0 plus g of 1.25 times 1.25. The widths are 1.25. Adrian, you're going to mark these that you're getting them correct, right? So you're like grabbing a marker here? Thank you. 1/2 g of 1.25 plus g of 2.5 times 1.25. Final answer, 37.112.
I have a question. You know how method 1, method 2 are right and left? So does that mean like you choose for, like if it's left, you choose the left, the endpoint, and then when it's right, you use
the left side of the rectangle. Okay? So, like if I've got some graph over here, and I'm saying go from here to here, you partition, you chop up the interval. And then if I say use the left endpoint, that means on this interval, which side do you use to determine the height of the rectangle? The left. So you go to the left and you go up, over, down. That's why this is the left endpoint method. If I wanted midpoint method,
So in the middle.
you go to the middle, and then you go up, and you make your rectangle that way, midpoint. Right endpoint method, you'd say, oh, go to the right, go up, come over, come down. That's the right.
Would there ever be a problem like that where we use more than one method?
No. No, I'll tell you one method for the whole problem. Sheila, then Jeanette.
For like the methods, doesn't matter. Because on the homework it says like how many rectangles you were supposed to draw. But then on the notes it was like different amount of rectangles. So like does it matter how many?
In the notes, it was an indefinite number?
No, it's like a different number.
Oh, yeah, I mean, the number of rectangles will change depending on the problem. I might tell you 80 rectangles. In fact, we're going to go to an infinite number of rectangles when we come back after Christmas. That's your reason to come back to school, so we can talk about an infinite number of rectangles, Diego. All right, everybody good? All right, please put that in the middle of the table, and please, if you wouldn't mind going around one last time, that would be great. And if everybody can turn in your packet to page 17, we're going to take a little assessment. You're going to show me what you can do completely on your own, no help from anybody else in the room. You've got 8 minutes to do parts A through D. Have faith in your smarticle particles. You're going to be okay. Now, Andy and Chris, you guys were absent. So, Andy, do you mind, Flora, do you mind working with Andy? And Chris, can you work with Paul? So the 4 of you are the only 4 that are going to be talking right now. Andy's working with Flora, Paul's working with Chris. Diego, were you absent too? You came late, but you were here. That's good enough for me. All right, here we go. 8 minutes. Page 17. completely on your own.
Yesterday.
And Rebecca, you weren't here. Okay. Wait, and you were out too. You got this? Okay. Make sure you read the question.
That's what
So this means number rectangle. But you're not gonna be able to use your calculator like that. Okay, so this is what I'll put that to do. So say this here. See you click.
Karina, we are filming, right?
Mm-hmm.
1.5. Put that view.
That's the width between each one. So you start at 0. Start at 0.
Oh, it's 1 over 4.
Oh.
It's just like where.
Yeah. Not how would you read it? Well, what does it mean? What is it that you're finding?
Four ways you can do it. There's the left, the right endpoint, trapezoid.
Which one? This one or this one?
What is it for
The next one?
No, yes.
I would have done the belt.
But like, what's
What's the point?
Yeah, it's this one, like this. Are you talking about this one?
this? What's
Like
up
the middle,
with
Like this? It's just like
the visual? Like, but like, what are you finding?
Just the
Just the area of this?
just the width.
What's the purpose of the graph? Or
Like, what are we trying to find? Like, the area, like, between this point and this point?
yeah.
Oh, okay. Who's your English teacher? I missed my life. Any good, huh? Yeah, but that was
So fine. You know how like you draw a dot right there, right?
area.
But you don't know the actual
So that's
boundary,
area
and you
was
can
second one.
not to like guess or like try to estimate. So what you would do is you would try to
So you basically, so
Like, okay, so it's like,
you know how the middle, the half point is 1.5 is 175.
you can't.
you can't estimate this one. So you have to
The
put it
original equation.
like,
2 minutes.
By the way.
475.
yeah, to the original equation.
What you do? Oh, yeah. So, sorry, so what is 1.5% area of it?
That's the width of
So you know the way
the
that
rectangle.
The width of every rectangle?
Every rectangle.
so once you plug it in, that gives you the height right for the
Okay. Good, what you get for it?
So that's when I was
That's
like,
So
the area of that rectangle is multiplied the height and the width.
So you put, so
Yeah, you can just do
1.5.
F. You can just do like F1.
yeah, it's like the area is based on height. This is 1.5. The height
No,
is like
the
whatever.
X is
You get where I got this one?
0.75.
Yeah, you got half from the midpoint. That's the midpoint, right?
Yes.
Oh, that's just these.
So you do so
So after you plug that in, whatever you get, right, let's say whatever you get, you multiply times the height so you can get it from the top, right? So that's how we can do it. Oh, you just put the equation like that.
Alrighty, friends. Time is up. Alright. So, let's take a look here. Alright, the first two seem to go pretty well. There was some initial confusion. I saw a lot of folks that wrote, the definite integral of this function with respect to x from 2 to 6, that's great. That's how to read it, but what does this actually mean? This is the area bounded from x equals 2 to x equals 6 by the x-axis and the function. You have to mention all four bounds. I don't care what order you mention them, but we're looking at area bounded by four objects, and you mention those four. Getting the value on the calculator, walking around, everybody had 26.613. Are all the friends in the room 100% okay? Good. Okay, now part C, that's what you needed to have. Walking around the room, I did not find anybody that had that. And if you have it and I missed you, Sheila, you're giving me the face of like you had it and I missed you. My apologies. Okay, so here, let me do this. Okay, whatever the graph looks like, I'm actually not interested in what the graph looks like right now. But I want the area from x equals 2 to x equals 6. And I want to use 5 rectangles, so how wide is each rectangle? 6 minus 2 divided by 5 is 0.8. Okay? Now, when I think about my interval, I'm starting over here at x equals 2, and each rectangle has a width of 0.8. So some mistakes I saw, people said 2, 3, 4, 5, 6. But if the width is 0.8, then the first rectangle starts at 2, and where does it end? It ends at 2.8. The next rectangle starts at 2.8, where does it end? 3.6. At 3.6. And then we go from 3.6 to 4.4, from 4.4 to 5.2, and from 5.2 to 6. That's the partition. Now, Diego, what method are we using here? What method are we using? It's not on the board, it's the right endpoint. So when I go and I come up with the area for the first rectangle, I look at how long is the base, 0.8, times the height. And this is the conversation we were just having. How do I determine the height? Is it f of 2? Is it f of 2.8? Jackie?
You graph that -1/4 into the graphing part of the
Okay, you're going to type that into the calculator, and then?
Whenever you go back to the scratch pad,
Yep.
whatever you have, and then you start plugging it in with 0.8 times f times 2.8.
Okay, f of 2.8, because it's the right endpoint method. So when I'm drawing my triangle, I know I didn't even go up to the graph, I start on the right, go up to the curve, come over, and come down. Which is why it's 0.8 times f of 2.8, f of 3.6, f of 4.4, f of 5.2, f of 6. What questions are out there? Because I'm going to give you guys a little bit more time to do the next one, which is a trapezoid method, and I hope it's going to go better. What questions are out there? Diego.
We just plug in all of the x, well, the points on x-axis into f of...
Into the function, because that's giving you the y value. It's telling you how high up on the curve do you go to determine the height.
And so the equation on top, that's exactly what I'm using the bottom.
Right, 0.8 times f of 2.8, 0.8 times f of 3.6. What I did to make my calculator life a little bit easier is I factored out the 0.8. Okay? Alright, 3 more minutes, do the next one. You can work with a partner on this one. I need to see much greater levels of success with part D.
So think of it as trapezoid.
Midpoint method,
So for me, that's 2.25. Then you multiply them by 2.3.
Right, because
So
when
the
you
first
find the
one,
answer,
the second one,
you divide it.
plus.
This is the reverse of the power.
So 1 times base 1 plus 3.
So I did everything, but I have to be simple.
0, right?
I don't know.
So you add instead of like
Okay, something's wrong because your function's not shown up in bold.
1.5.
Oh, it just doesn't
So you add
when you.
0.75.
No, that means something's
base
wrong.
1, for the trapezoid, this simple like
Okay.
So take
not
out
So
trapezoid.
0.75 you just have
So basically, this is a base and this is a base. What is my voice? Drop the base.
Oh, okay, I know what you're saying. So it was bolded when you typed it and then it's running. But it should definitely be that 25.932.
So what do you do after you? Alright, so you find the base. So right here the height.
Which graph do you fill in? What's this one? With this one?
This is
Okay, so this is 3. And this was 4.
no, yes. You gotta plug your
Wait, can we just calculate?
Is the base 3? No.
What is getting another
That's not necessarily this right now.
Oh, okay, I see.
So 1/2 base 1 plus base 2 times height. Why is your height 4?
Oh,
Yeah, that's the problem. I'm saying the base for this one is 3.
What type is this not?
base. Because see, you're trying to guess what the base is.
Trying to guess what the base is? What?
Now I get 25. 20, I get 25.
Yeah, I got 25.
So isn't it 27?
It's not exactly
All right, friends, here we go.
That's a funny one.
If all goes well, 25.550. How many guys honestly have 25.550? Okay, doing much better here. Same idea as before. How wide is each going to be? 6 minus 2 divided by 4, so you have a width of 1. A pretty kind width. Your partition, your interval is from 2 to 6. So I chop it, I chop it, I chop it. 3, 4, 5, and 6. Because this is the trapezoid method, when you make your trapezoids, there's a base, there's a base. You'll start off 1/2 f of 2 plus f of 3 times 1. 1/2 f of 3 plus f of 4 times 1. 1/2 blah, 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 blah. Or you factor out the common factor like we talked about before. Okay, so that's where we are. I want to end scene. We're not going to do parts E and part F. All the friends that are working, catching other people up, we're going to stop doing that. We've got about 20 minutes. And what I want to do over the course of the next 20 minutes is push your thinking further. Okay. I need you to find a new partner, somebody that you are not currently sitting with, so everyone's going to move. We need to make this a quick move, 30 seconds or less. Find a new seat, find a new partner, somebody who's way smart. Get a move, get a good move.
You want to stay here?
I was gonna move the table.
Michelle,
I'm looking for someone to instruct me and guide me on life.
Marilyn.
All right, everybody have a seat, please. Okay, all calculators, go away. No more calculators. I know I told you this whole unit was calculator active, and it isn't until when we come back in January that you'll have to deal with definite integrals without your calculator, but I'm getting the vibe that you guys are ready for this push. Not at all, but we're going to try it anyway. All right, trust your smarticle particles. Without using your calculator, determine the exact value of the definite integral from negative pi to pi of sine of x dx. I want to give you a minute with your newfound partner. See what you can do. Trust your instincts here. Do not touch your calculator. You reach for your calculator, I'll take off a finger.
So how does the graph of sine of x
I'll take off a finger.
Isn't it like the little curve? The lines? It actually starts with 1. The code starts with 0, right? I just think so.
No calculator.
That's the distance between the bases. The bases are these sides here.
Excellent. One person's got some good ideas.
You have like the choice of the graph.
Some people are drawing a unit circle, not so helpful. Hi.
The graph.
Pi is right here.
But you go up to the curve. And I'm going to see you all the way up to the curve. I gotta leave it. Sorry.
It does.
All right, friends, want to pull everybody together. Jesus. Jesus, I'm not looking for an answer right now. Conversations are done. What does that even mean? What are we looking for?
The area bounded by x equals pi,
X equals pi.
and x equals negative pi.
X equals negative pi.
The graph,
The graph of sine of x
yeah, and the x-axis.
and the x-axis. So you're saying if I know what the graph of sine of x looks like, you guys draw in the air for me what graph sine of x looks like? What does that look like? No, not the unit circle. The graph. The graph for the sine looks like that. I'm asking about the graph, not the unit circle. The graph for sine continues to do that thing. Negative pi is right over here. Positive pi is right over there. I'm looking for the area. How much area is there bounded by the graph of sine of x, the x-axis, from negative pi to pi? Jackie? 0. There is 0 area, Jackie. Why is that true?
Because the pi it's positive and then the negative pi area is negative, so when combined together they both cancel each other out.
Now, here's the thing. I want to be careful. I heard you say the area up here is positive and the area down here is negative. Does everybody agree with those two statements?
Yeah.
And you said when I put them together, they cancel out. Now, does that always cancel out any positive area with any negative area?
No.
Not
One
always.
can be more than another.
What if there's more positive than negative?
Yeah, if there was more then
They wouldn't cancel out. But this area is exactly the same as this area over here because of the nature of the graph. So that positive area exactly cancels out that negative area, and we get 0. And all the friends are okay? All right, see what you can do in number 2. 1 minute.
but what if it was like 1.5?
That's different. Good question, but that's different. These are carefully constructed questions to push your thinking. And Sheila, I can tell your neurons are on fire in this unit.
Yes. On the last unit, it said. Yeah. Which is greater than
About 10 seconds left.
We don't know.
Yeah.
4.
Let's say that we divide by 2.
And 1. All right, time to vote, friends. How many of y'all think that the integral from 0.1 to 10 of the natural log of x is greater? How many of y'all think the integral from 1 to 10 of natural log of x is greater? And how many of you have no idea, be honest? Thank you for the honesty. Look at the graph. Look at the graph for natural log of x. You have to know what that graph looks like. Natural log of x looks like that. There's a root at x equals 1. The common mistake that people are going to say this one is the bigger value is that they think, why would this be the bigger
It
value?
has more value. Like,
There's more room.
base.
So
There's a wider interval, right? It's longer. But look what happens. If you go from 0.1 to x equals 10, what happens, and I heard some whispers, you're capturing this negative area, and then you've got this positive area over here. What happens is you're losing some of this positive value because of the negative area. So I set you up to kind of fall for the trap. You have to think about the graph. It's all about the graph and your bounds. So I'd want to see something like integral from 1 to 10 of the natural log of x is greater because only contains positive area. All right. See what you can do at number 3. One more minute.
right
Which is why the Which is greater, a left endpoint approximation to the integral from -1 to 3, or a right endpoint approximation? We've got about 15 more seconds.
But you like use the right hand, you look at the right side.
Yeah.
Think about the graph. All right, closing out in 5, 4, 3, 2, and 1. Okay, which one's greater, left endpoint approximation or right endpoint approximation? How many are going for left? How many guys are going for the right? How many guys have no idea? Thank you for the honesty. My advice all the time is look at the graph. The graph of e to the x looks like that. If here's x equals -1, and over here's x equals 3. Now, I didn't tell you how many rectangles, but imagine partitioning this interval. If I use the left endpoint method, on each interval, you start on the left, up to the curve, come down. Start on the left, up to the curve, come down. Start on the left, up to the curve, come down. Up to the curve, come down. Up to the curve, come down. The black is your left endpoint method. The right, I'll do an orange. Up to the curve, over, down. 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 Which one's greater?
Right.
In this case, the right endpoint method is greater because the right endpoint method is going to give you an overestimate. You're getting more area than you want to, but it is because the graph is increasing. Paul. Oh my God, great question. How would you find the exact answer? That's exactly what these guys are working on right now. Jeanette.
Okay, so left, you start on the left and then move to the right?
Left endpoint method says on each interval you start on the left, go up to the curve, over and down. The right endpoint method says on that same interval, go to the right, go up to the curve, over and down. Midpoint, you'd go to the midpoint up to the curve.
So they will switch like overestimate and underestimate depending on the graph?
It has to do with the graph and the method that you're using. It's not just that left endpoint is always under or always over. Diego.
It's an overestimate.
It would depend if k was positive or negative. All right, friends, we're moving around to questions 5 and 6. 2 minutes. I'm hoping for greater levels of success here. We've had 3 shots. Show me what you can do. 5 and 6.
This has your
over.
Me gusta Pablo. Someone you have
You on the track?
Thank you, Marla.
Yeah, right.
One more minute.
It's an the left method does not start on the left.
So A is greater. So that means it's a negative. It's a negative number.
You start on the left and you go all the way up until the
Remember how it could be first in A? If A is higher, that's something else. That's different. I thought it was good. If A is greater, then B must be like a small number.
All right, folks, let's close it out in 3, 2, and 1. All right, I've got good thoughts going here. For the function f of x equals 1 over x squared plus 1, conveniently sketched over here, it does make my heart feel very, very happy. My little Grinch-sized heart feels happy when I see the graph, that parent survival guide, parent function packet, whatever I called it, coming on out. It makes me even happier when you can sketch this without looking at that. Oh, that makes me really, really happy. I want to find the integral from 0 to 4 of 1 over x squared plus 1. Left endpoint method. Some of you guys are still not 100% sure. However you partition, left endpoint method, you go to the left, up to the curve, over, down. 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 Overestimate or underestimate? Overestimate. That seemed pretty consistent. Overestimate. Overestimate. Because the graph is decreasing and using left endpoint method. You have to tell me about the behavior of the function and the method. All right, number 6. Let f be a function such that f of x is greater than 0, f prime of x is less than 0, and f double prime of x is greater than 0. What the heck does that even mean? F of x greater than 0 means the graph is above the x-axis. F prime of x less than 0, decreasing. F double prime of x greater than 0. F double prime, the second derivative is positive. This means concave up. Give yourself a quick sketch. I want a function that is above the x-axis, decreasing, and concave up. Is that even possible?
Yes.
Decreasing and concave up? Can you guys draw that in the air for me? Decreasing and concave up. Decreasing and concave up. Should look something like that. Doesn't have to be exactly this, but this is decreasing and concave up and above the x-axis. Okay. Which of these methods is going to give you an overestimate? If I use the left endpoint method?
Yes.
For sure. Left endpoint method for sure. How about right endpoint method?
No.
Right, if I consider my partition, right endpoint method, they're all going to look like that. So not the right endpoint method. How about midpoint method?
No.
Oh, I didn't even give that to you guys as a choice, did I?
No.
Trapezoids.
Wouldn't it be?
We're going from A to B.
Wouldn't it be like close to it?
Trapezoids look like that. Overestimate or underestimate? Imagine one great big trapezoid if you need to.
So instead of like having to type all of this out.
Over. If you went with two trapezoids, give me just a second, it would look like that. Okay, so left endpoint method is an overestimate, trapezoid method is an overestimate. This weekend's homework, pages 1 through 8, it sounds like a lot, it won't be that long. It'll be about 1 hour, but with the final exam on Friday, we